Welcome to Fins, Fur, and Feathers, the Fish and Wildlife Management podcast at K-State Research and Extension. I'm Dr. Drew Ricketts.
And I'm Dr. Joe Gergen. We're both lifelong hunters and anglers, K-State Research and Extension specialists who help citizens with their fish, wildlife, and pond management needs. If you've ever had a wildlife or pond management challenge, then this is the podcast for you.
We address common fish and wildlife management problems using a scientific approach to provide proven and practical solutions to the issues that you may be facing. Welcome back to another episode of Fins, Fur, and Feathers. We've got Aquatics up this week. So, Joe, what are we going to talk about?
We do. We're having a lot of fun. We're going to talk about parasites today, Drew. So if you're not feeling a little creepy crawly already, you're about to by the end of this episode for sure.
Well, parasites are kind of one of those nasty old things, but some parasites are pretty cool.
That's a biologist speaking.
It is, yeah.
I had a parasitology professor that let a bot fly grow up in his arm just to see what it looked like. He loved, showing that thing crawling around. Ugh, gives me the creepy crawlies. I like them. They're neat animals, but they don't need to grow in me at all.
No, definitely not. I've seen bot flies growing in mice and rats,
yep.
and that's definitely not something I would want to have in my body.
For sure. We're going to be talking mostly about parasites that are in fish and aquatic animals today. So not human parasites, but still some really cool critters.
Cool.
So, I was down in Florida recently doing some fishing on the Gulf Coast, and there must be something going around on social media because I had a few people come talk to me about tongue-eating louse, and it's like an isopod, which like a roly-poly is an isopod, right? But they climb into the mouth of the fish, they get into the gills, and then they climb into the mouth. They use their pinchers to sever the blood vessels going to the fish's tongue, and then they grasp on. Some of them eat mucus from the fish. Some of them grab onto different blood vessels, and they serve as a tongue for that fish for the next few years of their life cycle. So anyway, if you reel on a fish and it has this critter living in its mouth, and if you look up the pictures of it, it's startling, right? And if you were to reel one in and see that, it'd be kind of surprising. But I thought, hey, it'd be a fun thing to talk about.
Well, it sounds like something off of War of the Worlds or Predator or Alien or something like that. I can't imagine. Yeah, what would you do if you were out swimming around and all of a sudden you realized that you had a critter take the place of your tongue in your mouth? I mean, that's crazy.
It would not be very, very exciting. For sure. I'm not sure I'd want to keep going, but they're one of the few parasites that replace an organ, so they're going to replace that tongue, serve kind of the same function, don't really impact the fish all that much.
Really?
There's been some studies that have shown maybe a small decrease in body condition, so maybe a little bit lower feeding capabilities or something, but for the most part, fish can live really long times with these parasites in their mouths.
Wow. Is there anything else noteworthy about these tongue-eating lice?
The big thing I think that I got giggles from is that they're hermaphrodites, and so they're called protandrous hermaphrodites.
What in the world does that mean?
Yeah, it's a fancy word, make me sound smart.
Yeah.
And so these are they're males when they're little, so they're juveniles. They go attached to the gills and they're males, and then once they attach to the tongue, they have some shifts in their body and they become females. So they can retain male and female organs, so they can reproduce sexually. But they have both sets of organs, so they can use them depending on what's around. Studies are kind of up in the open about how often they can reproduce, but they can make lots of babies, and just an interesting life cycle where they have kind of that shift from male to female.
That's crazy. So did you say that they're all born male, and then they attach to a fish, and they turn into females?
Yep.
And how long do they live?
We don't know that for sure, but we think a really long time. And so definitely years. They think there are studies where they've shown they think they live up to 40 years. Fish have been infected for really long periods of time. That hasn't been replicated really well, so it's hard to say. This is something that just hasn't been really well studied. It's hard to know. There are examples where fish have outlived, or at least we think they outlived the isopod. So the tongue is gone. There's residue or there was examples that the isopod was there and it no longer is, but we don't know for sure.
That's crazy.
Yeah.
I just can't imagine. So I've got all kinds of questions now. Yeah. Do they have indeterminate growth if they can live that long? Do they continue to grow as the fish grows and do they stay the size that the tongue ought to be as that fish gets bigger and those sorts of things?
Yeah, there's a ton of different species that of these louse, and so Most of them do not keep growing. They reach a certain size and they stop there, but they can infect all sizes of fish, right? And so most of them are smaller. You can have more than one individual affect a fish, so you can have multiple louse inside of one fish mouth, for example. Most of the pictures that you're going to see if you Google this right now, you're going to see one. It's going to look really pretty. In the real world, if you were to reel in, snapper are really common to be affected. You could see these in different places in the mouth. There could be lots of them in there. So creepy, crawly little critters to think about.
So if you look in their fish's mouth and it looks like they got 4 or 5 tongues, it's probably lice.
Probably lice, yeah. Just throw the fish overboard, move on. Either lice or too many beverages while you've been out there fishing.
No kidding. So you said in snapper, do we have these here in freshwater systems in the center of the continent?
Nope, we do not. Okay. So these are primarily found. They're found in the Pacific Ocean a lot. Out on the West Coast. There's some in the Atlantic. They're a little bit less common there. There's some in the Gulf down south too. So they're around a little bit, but they're not found in freshwater. These are saltwater species.
Interesting. Anything else about these tongue-eating lice that we forgot to talk about?
No, I think that's pretty good coverage. Okay. They're fascinating, right? So it's, like I said, kind of creepy crawly, but just fun to talk about.
Yeah, no kidding. So what's next in our lineup of crazy things we're going to talk about today?
Crazy critters. Well, switching a little bit from saltwater to freshwater, there are types of lampreys, and so sea lampreys are one where they're living out in the ocean a lot, but they'll come into freshwater too, and so they're kind of like a little snake-looking critter. They're actually a fish, but they just like a long tubular fish, kind of look like an eel maybe.
Yeah.
But they have a circular mouth with really kind of crazy teeth on it. And they can bite onto a fish. They'll actually grind a little hole into the fish till they can get down to the blood, and they'll eat off of that fish for a little while. So we'll see those more commonly, kind of in freshwater systems. These fish are migrating really long distances, right? And so these migration patterns, we've put up a lot of dams, so we don't see them in the middle of the country as much as maybe we historically would have. But they certainly used to be in our neck of the woods.
Wow.
Brook lamprey, smaller version of the same thing. And so these fish that are kind of grabbing onto the side, again, these are, you're not going to go see them in your backyard pond every day, but they are fish that we could have seen in freshwater settings for sure.
So like Lewis and Clark, when they were on the Missouri River, maybe they caught a flathead that had one on it or something like that, or a sturgeon or a paddlefish.
Yeah, they certainly could have. Crazy. For sure. Yeah.
Huh. That's nuts. So, okay, I grew up being like fascinated with sharks. So you're talking about lampreys. Are lampreys the same thing as those fish that we see that kind of stick to the side of a shark, but then go off and gobble up little pieces when the shark is shaking his head and loses stuff?
Those are called remoras.
Okay.
And they kind of have a little vacuum, if you look at them, like a suction cup on their head. And so, they stick themselves to the body of that shark, and they're eating a lot of, like, when a shark bites a fish, it's not just everything goes in its mouth. There are a lot of little pieces around.
Yeah.
So those remoras are kind of gobbling up the waste, I guess, from that shark bite. They're not directly feeding off of that shark. So lampreys are a little bit different because they are a parasite.
Yeah.
That parasitic relationship means that there's a negative for one animal and a positive for the other. And there's no real negative for the sharks to have remoras around. Right?
Okay.
So it wouldn't be parasitic because there's not a negative effect of having those remoras there.
Interesting. So first critter we talked about is an isopod, so an invertebrate. Now we're talking about a fish that's a parasite on other fish.
Yeah.
And what are we going to talk about next?
Well, I think that's a good, that's a good point that you just made, because a lot of animals, the estimates are 40 to 50% of all animals, vertebrates and invertebrates that have been discovered, have some parasitic aspect to their life, right? So it's very common. This relationship is very common. This parasitic relationship is very common. And it's widespread, and a lot of time we see them in ponds too. So, I just want to point out, really common to see this across the board everywhere we're at, but also common to see them in your backyard pond.
So what kind of parasites might we see in our pond?
Yeah. The most common ones that we'll see are things like yellow grubs. And so if you go catch a bass or a bluegill out of your pond, I show people all the time, you open up their operculum and you can look and see the red of their gills. You don't ever want to touch their gills. Lots of blood vessels and really thin blood vessels. So if you touch their gills, you can really hurt them. But if you look there, you might see little white specks on those gills. Or if you look on their fins, a lot of times you'll see white specks. And so the most common parasite that I see in Kansas is called a yellow grub.
Mm-hmm.
And that's just a little parasitic fluke that gets into fish, into bodies of water, and affects the fish. You might see it when you're cutting open a fillet, little white cysts in the fish. Yeah. And so that yellow grub is the most common parasite that I see around Kansas. They have a really interesting life cycle where we see them in the fish generally, but the goal of the parasite is for that fish to get eaten by a bird. And inside of the bird's digestive tract is where these parasites grow up and reproduce. So that's kind of their end host is the bird. The birds then will fly over a pond. They'll leave some droppings in the pond that have a bunch of eggs in it. Those eggs will hatch. Parasites go find a snail, and they grow up in that snail. And then when a fish eats that snail, the parasites infect that fish. That's commonly when we see them. Mm-hmm. And then that cycle continues. So that snail is called an intermediate host. Without that intermediate host, we won't have that life cycle. But yellow grubs are most common parasite that I see around.
Crazy. So like, let's say a great blue heron's going along and it eats a green sunfish that's got these yellow grubs in it, and they turn into whatever they're going to turn into inside that heron. Is it a roundworm? Is it a tapeworm? What's that turn into? And I mean, inside that bird?
It's a fluke. It's a type of flatworm that we would see. So really small, little. I mean, it looks like a kind of an inch long. They kind of have like a little triangular shaped head, but just a little worm that you'd see inside of their digestive system.
Okay. So they can look like that in the fish, but normally not.
Yeah, normally, almost always, they're going to do that inside of the bird, right? And so the end host, when they're going to grow up and they're going to be adults, is going to be inside of that bird. Almost always. They can do it in a fish. It's pretty rare to see that. Yeah. They have not been shown to affect humans if you cook the meat. And so if you fillet your fish and you see a bunch of white spots or you see some little worms in there, cook the fish. Right? Okay. I don't hope I don't have to say that, but if you cook it to the right temperature, they're safe to eat, right? Yeah. And so, it might be a little yucky if you see them, cut them out, if you don't want to eat them. But if you were to ingest one, you're probably safe. Even if you were to ingest one, they're not known to be zoonotic, but to be safe, make sure you cook the fish and then eat them.
Okay.
Yep, they're safe to eat.
So no backyard sushi.
That'd be preferable, yes.
I've never, sushi just doesn't sound good to me. Really? And I always told people, if I was going to eat sushi, it'd be fish that I cleaned and I knew where they came from and I knew how old it was and how it was handled and all that kind of stuff. But now I'm thinking that might not be a very good idea.
When we were in Florida recently, we caught a wahoo when we were out on a trip, and that's supposed to be one of the best fish that you can eat. And so when we got back to the cleaning station, my son was really excited to eat it. He didn't understand. Maybe we should cool it off. But, so my dad, my wife, my son, and I all had a slice of this fish right off the dock. So I'd recommend chilling it first. If you are going to eat it, maybe have some soy sauce nearby. But I'm a big sushi fan. I could eat sushi all day long.
Was it good?
It was good. It was better when it was cooled off and you had a little soy sauce with it. But very clean. Just a very mild fish flavor. It's really good. So
interesting.
It's fun. It was fun to kind of slice something off and everyone be a little bit disgusted about it, but still chew it down. Hopefully we don't get parasites in the next few weeks.
Yeah, no kidding. All right. So what other kind of parasites might we find in our pond?
Yeah, black spot disease is really common too, and that's going to be similar to that yellow grub. You're going to see black spots. It's really common in bluegill for some reason, and so you're filleting that meat, and instead of seeing in like little white spots, you see black spots. An interesting thing, those black spots actually aren't a larvae. They're not an egg. It's the fish immune response causes that black coloration most of the time. So. But if you fillet it up and you see black spots on the flesh, it just looks funny more than anything. Just make sure you cook that fish. Same life cycle, similar, everything's kind of similar, just different species that causes that similar problem.
I know one time we were in northern Minnesota, or we might have actually been in Michigan when I was a kid, and we were definitely in Michigan because we were fishing in a creek or a river that flowed into Lake Michigan, up by Traverse City, and we were just catching rock bass left and right. And we caught all these rock bass, or at least that's what I think they were. And we kept them. And Dad told me, now I'm going to clean these before we go home, and don't tell anybody about all these worms that are in them. And they had those black spots all over them, but then they had those little, the white grubs in them too. Yeah, they were pretty nasty and wormy. But he said, as long as we cook them, it's not going to be a big deal. Just don't tell the wives.
Exactly. It's one of those things that if you think about it too much, it really is not appetizing. But if you cook them, they're safe to eat. So I think that's the important thing. So
cool. So what else? What other kinds of parasites might we see?
I see anchor worms fairly commonly. So if you reel in a fish and it almost looks like a hair growing off of it, kind of like a half inch or an inch long, like a really thick hair. But those are really common, called anchor worms, but they're actually not worms. They're little crustaceans, so similar to like a shrimp type deal that they get between the scales, they grab onto that skin, and they kind of just hold on tight. And so anchor worms are really common. Ick, I think a lot of us are familiar with ick if we had an aquarium growing up. And so ick is a fungus that can get on the it looks like a fungus. It's actually a protozoan parasite that can get on the fish, and it makes these like flowy white kind of stringy type deals that come off the fins a lot, or the gills. And so we see that a lot in aquariums. It's really a strong indication that the water quality is really poor. Ick seems to be common when we have really poor water quality. It can get on the gills and make it really hard for the fish to breathe. So in an aquarium or in a pond, we might see fish gulping air a lot. If you get ick into a pond, it's very hard to control. And so one of the first things we recommend is, as soon as you see it, try to get every fish that it visibly has ick out of that pond and get them away from that pond. You don't want them to get, to decay and it wash back in the pond. So getting them away is really important. If it's a small pond, you can add salt to the water. That helps boost the immunity of the fish that are in there, making sure you're adding the right amount. But if it gets really, really bad, they make medications that you can put into the water of the pond. Make sure you understand where it's flowing and follow the recommendations on the label, obviously. But there are ways to treat it. If you get ick in a pond, it can be pretty bad pretty quickly. So, make something that we'd want to be aware of and control if we could.
Yeah, for sure. The place where I've seen ick the most in wild fish is when I've caught green sunfish or bluegill for bait, and then put them in like one of those minnow buckets that's for flowing water. And then I go to the river and I've got that minnow bucket, and they've been beaten against the side, from the current in that minnow bucket. And then at the end of the night when I'm fishing or whatever, I get in there and get them out, and they got all these nasty fuzz growing on them and stuff. So
a lot of that is, fish have a slime that covers the outside of their body. And that if you've handled a fish at all, you get all that fish slime. I think it smells really good, but I'm one of the weirdos that like that fishy smell. So, but that slime helps protect the outside of their body. So if you're handling them a lot, or they're getting smacked against the side of a bucket, we're getting rid of that slime, and that's going to allow that parasite to just explode, right? And so it'd be similar to, if we rubbed our skin too much and we got a sore, and then, something wanted to come infected, it'd be a lot easier for that to get infected than if we didn't have a cut in our arm.
Sure. So, same sort of thing.
Same sort of thing, yep.
Yeah. Cool. Well, what about frog mutating flatworms, Joe?
I think I wanted to point out that, it's not just the fish that get affected, right? And so these frog mutating flatworms are really cool. And so I don't think they're in Kansas. They're more northern, northwestern.
Okay.
And they affect the tadpoles. And so you get these flatworms that get into the tadpoles. And based on how many of these flatworms are affecting a tadpole, they're going to grow different extremities. So they might have an extra front arm if it's a small number of flatworms that are affecting these frogs. They might grow 2 extra back legs if it's a lot of these flatworms growing or affecting the frog. And we don't really know why that happens. We think it might disrupt their growth hormones as they're transitioning from tadpoles to adults. There might be, something going on that they're giving more hormones, or they're saying, hey, they're disrupting the signals that are being sent out. We don't know what the mechanism is, but the frogs end up having too many appendages. And the reason that scientists think that happens is that, again, these parasites, part of their life cycle is to ultimately get into a bird, which is their end host. And so if the frog has extra legs, it probably has a greater chance of being eaten, right? And so the parasites can manipulate the frogs, and we can see weird things happening.
So you're telling me that birds select which frogs are going to eat based on how many frog legs they've got?
Hey, maybe it's something else going on. But yeah, if I was a bird, I'd want to eat more frog legs. Frog legs are good to eat.
They are, yeah.
I think it's not necessarily the number of legs. I think it's going to be that those frogs are less. They're not as good at hoppers, or not as good as swimmers, and so that's why they're getting eaten. But I think. Was it John Madden that had a chicken with like 8 legs or something, or a turkey with 8 legs for Tofurkin? Tofurkin or something, yeah. So maybe it's a conspiracy by the birds to get extra legs on their frogs. Who knows?
Maybe.
An important thing there, again, the snails are an intermediate host, right? And so it's snails. Now we're going to tadpoles and turn into frogs, and then back to the birds. But those snails are an intermediate host.
So having snails in our pond might not be a good thing.
Well, it's not something that we necessarily, it's not a bad thing necessarily, but it's not something good. It's something we'd want to definitely keep in mind.
Interesting. While you're talking about frog mutating flatworms, I can't even spit that out. I was cleaning frogs one time for frog legs that I caught in a kind of a stagnant, nasty old pond one time, and they were full of what it looked like the same white grubs that you'd find in fish. Can they infect frogs too?
Yep, they can infect tadpoles. You can see them in frogs. And so the most common life cycle would be the fish, but you can find them definitely in amphibians as well.
Okay, interesting. So what causes parasites in ponds?
Parasites are common, like we talked about. So 40 to 50% of all species have some parasitic stage, right? And so it's common for parasites to be in a pond. A couple things that can lead to more parasites, having stagnant water, that can lead to more parasitism. Poor water quality, and it's not necessarily that poor water quality leads to more parasites, but what it does is it stresses out the fish or the animals that are in the water, and so that lowers their immunity, right? Their immune response, and so they're not able to fight off the infections as well, and so we start to see higher amounts of parasitism than we would if the fish could be happy and healthy and their immune systems could work as we wanted it to. One of the common things I see people doing is taking fish from one area to another. They go catch them somewhere, they throw them in their pond, and that's a really easy way for parasites to get moved around. And so, I think a lot of times it's good-natured. There's a lot of reasons that we wouldn't want to transport fish from one area to another. It might be better to buy them from a reputable dealer, for example. But, those are kind of some of the common reasons that we'd see a lot of parasites in our pond.
Interesting. And just so everybody understands this, it's not legal to move most fish around, at least in Kansas.
Yeah, that's definitely true. Private pond to private pond, if they're your fish and a private entity with no flowing water from area to area, then it's legal, but most of the time it is not.
So if I go out to my pond, or if I go to a new pond that I haven't fished before, and I start catching a whole bunch of fish with parasites, I mean, is there some kind of chemical I can go buy and dump in the pond to take care of that, or what should I do?
There are chemicals that can help with parasite loads. But what I generally recommend when I go meet with people, one, we look at the water quality and we figure out, is there something we can do? Do we need to get more water? Do we need to get the water moving? That's kind of number one to look at, is the water quality. The other thing that we've mentioned a lot is the importance of snails in most of these life cycles, right? That snail is that intermediate host. And so we need those snails in order for the parasite to get to a stage where it can infect a lot of the vertebrates that we care about in our pond systems. And so adding a fish that can eat those snails helps drastically cut down the number of snails that we have and the number of parasites in our pond. In Kansas, the most common fish that we add is called a red ear sunfish, right? And so red ear sunfish, they tend to live a little bit deeper. They have a little bit smaller mouths, but they're also called shell crackers, and that's because they love to eat snails.
Yeah.
And so if you throw some red ear sunfish in when you're adding bluegill, or if you just see a lot of parasites, you can go add them to your pond most times without many detrimental effects. And they'll eat those snails, and they'll help to cut down the number of parasites that we might see.
So, let's say I got a 1 acre pond. How many red ears should I put in there? I mean, I assume if I got a lot of snails, then I ought to put a whole bunch in there, right?
Yeah. That's going to depend on a lot of things, on the size of the fish we're adding, what's already going on in our pond. But kind of a good area to start, if we're adding 500 bluegill to our pond per acre, which is the recommendation, we'd want about a quarter of those to be red ear sunfish. Okay. And so if we think about that, if we're just going to add them in to help control some of these parasites, somewhere around 125 per acre of little 2-inch red ear would be a good place to start. If you already have a bunch of bass established in your pond, you'd either want to make sure, one, you have a ton of habitat for these red ear to survive in. They're going to want things like a cedar tree with lots of small interstitial spaces and a little bit deeper habitat, or you'd want to have bigger fish, so maybe 4 or 5 inch red ears that we're adding. And if we did that, we'd probably cut that number that we're stocking in half, so add 60 to 70 of the larger size red ear sunfish. That'll allow us, over time, they'll reproduce, and we'll start to get fish in a big enough abundance that we can control those snails.
Cool. So the red ear eats snails. Do they also eat other things that a bluegill might eat? Or are they going to compete with the bluegill in our pond?
Yeah, they might compete a little bit. The red ears tend to be deeper than the bluegills, and so there might be a little bit of competition with, in general, not all the time, but in general, food is not a limiting factor for the smaller fish that we see, for the centrarchids, the sunfish. So bluegills, red ear sunfish, those types of things. They're omnivores, so they're flexible in what they'll eat. Generally not a problem having enough food for them. When we start thinking about predators, we get up the food chain. Having the right size food is really important. But for these smaller panfish, there's generally enough food naturally in a pond for them to all survive together.
Awesome. Well, thanks for bringing this topic, Joe. I know I learned a lot today. I didn't know a whole lot of this information about parasites and everything, so I was glad to learn about it. I'm sure lots of our listeners will too. So thanks, everybody, for listening. We'll talk to you again in a couple weeks with a terrestrial episode.
Fins, Fur, and Feathers is hosted by K-State Research and Extension and is part of the Natural Resources University Podcast Network.
The network and this podcast are supported by the Renewable Resources Extension Act.